Hi class, in this video I'm going to show you how to do hypothesis testing using Excel about a population mean when sigma is unknown. The file will be available on Blackboard. The title of the file is HYP, hypothesis, sigma unknown. You can download it. So the data is stored in the very first column over here, and we are going to assume that we don't know the sigma for the population, and we're going to test the hypothesis in which the null hypothesis is mu is less than or equal to 7, and our alternative hypothesis becomes mu is greater than 7. We're going to start by finding out the sample size using the function count. Okay, so we're going to start from the first cell, which is A2, where the data is, and then go all the way to the last cell. So that's in A61. Come back here. Okay. So the function is count with input from A2 to A61. So we have 60 sample points. And the sample mean, in order to figure out that, we're going to use the function average. Right here. The input is the same from A2 to A61. Make sure you include all the data points. So the sample mean turns out to be 7.25. And then, since we don't know sigma, we're going to calculate the standard deviation for the sample using the function std standard deviation dot s for our sample. Okay, so the input remains the same, all the data points from A2 to A61. Close bracket. So it turns out the sample standard deviation is around 1.05. The hypothesis value, which is the mu value in our hypothesis, is 7. I'm just going to key in 7. And now we can find out the standard error, sigma x, which is sigma. In this case, we're going to use standard deviation here divided by square root of n. And n is the sample size. So it's about 0.136. And now we're ready to find the t-value. Now we're ready to find out the test statistic t-value, which is x minus mu over sigma x. And in this case, we're going to use the standard error here. So x value, sample mean, I'm going to give it x value minus mu in our hypothesis, 7, divided by standard error. So that's about 1.84. And degree of freedom depends on n value, which is n minus 1. So sample size minus 1. In this case, it's 59. Now we're ready to find out the p-values. If we're doing a lower tail test, we're going to use the function t dot dist, t distribution. So now the input, we're going to start by keying in the x value, which is here, and then degree of freedom, which is here, and then the last input we're going to select true because we're looking for cumulative. Okay, so that's 0.965 if we're doing a lower tail test. If we're doing an upper tail test, that's just 1 minus this value we found. And if we're doing a two-tail test, it's going to be 2 times the mean value among this guy and this guy. And in this example, we're doing an upper tail test. So notice the p-value for the upper tail we found is about 0.0353, which is less than the alpha value, and we chose it as 0.05. That means the null hypothesis is rejected.